Ryan, and I'm here to explain how a permanent magnet DC motor works. So, I have my demo right here. First off, we have our armature, which is this piece. It's kind of wound in a counterclockwise motion, meaning that when current is induced, it's going to flow through this side, around in a counterclockwise motion, and then out this side. The yellow lead is our positive current side of the battery, the blue lead is the negative side of the battery, and this blue thing right here is my permanent magnet. It's a neodymium magnet that gives me a magnetic field kind of pointing upwards. So it's going to, because the north side is up, so it's going to go, my magnetic B is assumed upwards. And to explain how this is going to spin when it first starts, I have these diagrams. This is our right-hand rule on the bottom coil, because that's the coil that's going to be, the bottom side of the coil, because that's where we're going to see the most force. We're not really going to see a lot in the top coil because it's so far away from the magnet. And this is just kind of a circuit diagram of where the current is going to go. We got our I coming in, going around a bunch of times, and then coming out and going to the negative side. It's going to cause it to spin counterclockwise due to Bill's law. Okay, so let's test this theory. Or clockwise, I apologize. This is going to spin clockwise in effects of this direction. So we're going to give it a little boost and knock it off its pedestal. Okay, there we go. And with a little boost, it starts spinning. So the way I kept it from reversing every time it tried to stop that before it tears itself apart. So if you think about it theoretically, if both sides of the wires were stripped all the way, every time it flipped poles, the current would change direction, would not change direction, and it would try and reverse the spin of the motor. Since we didn't want that on one of the sides, I only stripped half of it. That way it would predictably spin in one direction. Okay, so now that we've seen which direction it'll flow this way, let's look at what happens when we reverse the leads. So real quick, I'm just going to reverse the yellow and blue wires, and let's look at this. Give it a little bump. It should spin the opposite direction, which it is. It is now spinning counterclockwise in respect to the direction I showed you earlier. Okay, let's see how this works. So, it's spinning down now because I unplugged it. We have our same drawing, except you see that the current is reversed. It is now flowing through the other way, that, and our right-hand rule. So our current is now reversed, meaning that our force will be reversed because our B stayed the same. Thank you for watching, and I hope you have a great day.